good morning everyone. Today I will be talking about the lesson 13, calculate electric field in the region given a mathematical function describing its potential in a region of space. So we have three learning objectives. The first one is understands the relationship between the electric potential and electric field. The second, derive the electric field from a given potential function. And the last is solve simple problems involving potential and electric field step by step. So what is electric field? Electric field is the force per unit charge experienced by a small positive test charge at a point. It tells how strong the force is and in what direction the charge will be pushed. So the formula is E is equal to F over Q, where E is the electric field, F is the electric force, Q is the charge, or coulombs. In simple words, the electric field is like the wind that pushes charges. Stronger, stronger field, stronger push. Next one is what is electric potential? Electric potential is the electric potential energy per unit charge at a specific point in space. It tells how much energy a positive charge would have at that point. So we have this formula, V is equal U over Q, where V is the electric potential, while U is the electric potential energy per joules and Q is the charge. So in simple words, electric potential is like the height in gravity. The higher potential, more electric height. Charges naturally move from high potential to low potential. So the relationship between electric potential and electric field, they are connected by E is equal to negative dV over dx. This means electric field points toward lower potential. The steeper the change in potential, the stronger the electric field. So kani, if V depends only on x, so there is a formula na E sub x is equal to negative dV over dx, where E sub x is the electric field component along x, while dV over dx is the rate of change or the slope of potential with x. So if computed E sub x wait is greater than 0, the field is in positive x direction. If A sub x is less than 0, field is in negative direction. So, ang magnitude of um, absolute value of A sub x is how strong the field is at that point. So, we have some examples. So, the problem is given V given the V is equal to 6x plus 2. Units are volts where x is in meters. Find electric field along x and show steps and interpretation. So the step 1 is we need to write the formula. Since the formula given in our previous slide is E sub x is equal to negative dV over dx. So write the given. So V is equal to 6x plus 2, then there i-substitute na since ang dv over dx is equal 6, then apply the negative sign. So 6 so the answer is negative 6. So the magnitude is equal to 6 vm negative sign fields point in negative x direction toward decreasing potential at any point x. Field is the same. So the next is the v is equal to 2x squared. Find e sub x as x is equal to 1.0. So same process, write the formula, then differentiate dv over dx is equal to d over dx. Since given ang v which is 2x squared is equal to 4x, so apply the negative sign. So since negative sign, so negative 4. Evaluate at x is equal to 1.0. So negative 4 times 1.0 is equal to negative 4v over m. So the answer is negative 4vm. So forgetting the negative sign means wrong direction. So treating partial derivative as full derivative in multivariable problems. Ignoring units, differentiating constant incorrectly. To avoid this, we need to write the formula first, compute derivative correctly, then apply minus signs and units. So we have real life applications. So capacitor plates, constant potential difference, near uniform field between plates. Electron beams or CRT, potentials, direct motion via fields. Medical electrodes, potential differences produce field across tissues. So the importance of electric potential and electric field is that they help us understand how charges move. They allow us to calculate forces on charges. They are used to design electrical devices, important for safety in electrical systems, used in medical equipment, and lastly, important in communication technology. So to sum up, electric potential describes the energy per unit charge, while the electric field describes the force per unit charge. They are connected by the formula E sub x is equal to dV over dx. This means the electric field points toward lower potential and its strength depends on how fast the potential changes with distance. By differentiating the potential function, we can easily calculate the electric field in a region of space. And that would be all. Thank you.